Hey, it's the Reckless Retiree with my balloon of hydrogen. And so I'm going to take this to the next stage. And I'm going to make a few modifications. Now I said I was going to hook up this spout via a hose. And I was going to hook that up to my 55-gallon drum gas storage device that I made. I've shown that in previous videos. I have two exercise balls in it. One at the time I was filling with hydrogen, and the other one with CO2, with the idea of filling balloons with, first, we have a balloon in a balloon. The inside balloon would be filled with hydrogen. The outside balloon would be full of CO2, or not full, but it would have CO2 in it. Hopefully it would float, and then I would then have a protection for the hydrogen as to not catch on fire. And I have lots of videos on that. You can go back and check those out. But instead of using that today, what I'm going to do is I have some large Mylar balloons. And what I was really after was no back pressure on the hydrogen being made. So what I'm going to do, and the other thing I want to change is I'm in the garage, and it's obviously, well, it's not obvious to you, it's obvious to me, it's cold out. It's in the 30s. Okay, so what I thought I would do first is use my infrared temperature reader and read the temperature of the bottle. So the bottle is 31 degrees Fahrenheit. And of course the balloon would be similar. Yes, 31. So this is the plan. Take the bottle inside, put the spout in it, hook a hose, a small section of hose to the spout, and then hook that to the Mylar balloon. Then the temperature of the whole rig will increase by being inside, but also while I have it open, I'm going to add more lye, more hardwood ash water, maybe up to the bottom of the stem. I want to have a little bit of room there for a reaction, but what I'm finding with this hardwood ash water, it doesn't bubble up and heat up as though you were using the concentrated lye. So it's a much slower process, but I'm thinking if I have it inside and it heats up to 68 degrees, then it'll be twice the temperature. I'm thinking that it will make the hydrogen even better. And then with additional lye and additional aluminum, hopefully even more, and then no back pressure, even more, and hopefully I can fill up that Mylar balloon right? So, here in a minute I'm going to go inside with all this rig. My wife's not at home, and I'll tear it all down before she gets here, so she'll never know. Shh. Anyway, we'll have a little fun with that. Okay? The remote on this phone that comes with the tripod is kind of haphazard. All right, so what I decided to do before I take it in is take the balloon off, tie it off. If I can, my hands are kind of bunged up from the explosion I had, and I can see bubbles coming up through the surface of the lye. And those bubbles would be, oh come on, hydrogen, right? So what I'm going to do is take the balloon off and see if it'll float. Should float. I used to have some ribbon here for tying off such balloons, but I don't see it, so I'm going to have to go find it. Anyway, take it off, tie it off if I can. Probably should have a way of tying it off. I have some zip ties here. I can go with the old zip tie technique if the old fingers won't tie the balloon. We'll see. It's been a couple of weeks of healing. So I am going to, yeah, it's really bubbling. Man. So with additional heat, with additional lye, with additional aluminum, then we should have additional, what? Hydrogen! Right, I knew you knew. All right, so here we go. Pinch it off, pull it off, twist this son of a buck, and see if I can do this. I think I'm gonna pull it off. All right, I did it. Okay, will it float? Oh my goodness, it doesn't float. So that just means, I think, well, I know, that the balloon material is heavier than the hydrogen within. Because I know there's hydrogen within. And I will prove it to you here in a moment. Okay, I'm gonna use this rig I got there. Set this bad boy on there. Whoa, I said bad boy, come on. All right, got me butane torch. And here, let's see what happens when I light her up. Baby, I say, oh baby. There's some hydrogen in there, folks. All right, that is very encouraging. That's the word. All right, bottle of lye, wine bottle, Mylar balloon inside, and we shall proceed, comrades, in this endeavor to further the power and strength of the old country, of the mother country. Yeah? Okay, I moved inside, as you can see. And I have the bottle, which is half filled with the hardwood ash water, and the one roll of aluminum that I've been making the gas with. As you saw, I ignited the balloon. So I have the funnel here, and I have the additional lye. Now, I want to give you a warning here, because as you say, this lye, or this, hardwood ash water, looks just like tea. And I have it in a tea bottle. Okay? So, whoa, what if somebody drank it? So, I have lye written on the bottle. Hopefully they can read. And there's a layer of ashes on the bottom. Hopefully that would scare them off. But anyway, you need to be careful. That's why I got my gloves on. All right, so here we go. Additional lye. It does have a rather unique odor to it, like a fireplace on steroids. All right, so there's that. Now, before I put the additional aluminum in, I want to show you my lovely assistant, Accidental Andy. I chose him to let you know what can happen if you mess with hydrogen. All right, so actually it's left over from Halloween. So here is the wine bottle or olive oil spout. And I bent over the air intake, which, you know, allows it to flow more easily. I hope that takes care of any leakage. This has an external bit of pipe right here. Okay, it's positioned just right. Anyway, it's not focusing on it for some reason, but anyway, hopefully that doesn't allow anything out. I bent it over, as you see. I flattened it and bent it over. So hopefully all the gas is coming out the main spout. I have that into a piece of plastic tubing, which then goes into the balloon. I think this will work well. But in addition to that, I am going to zip tie the balloon to give it that much more, much less chance of leak. That's what I'm trying to say. So here we go. Now I'm going to use these patent pending zip tie cutter off when you're making a balloon tool, otherwise known as side cutters or dikes. We call them dikes in the Navy. I'll let you figure out why we did that. All right, so here we go. Zip that, or cut that off. Okay, so we should be good to go. So here's my additional chunk of aluminum. Just shove that bad boy down in there. Little shake. Now we're going to push this baby into here. Now, what I've found in the past with this kind of a fitting, if you will, is that if I make too much hydrogen, if I have too much of a reaction, it will block off the gas escape and then push this out of the mouth of the bottle. That's what happened to me in the shed in the back. But because this is not concentrated lye, it's hardwood ash water, I'm hoping that will not take place, because as you saw, to get as much gas as I got in the previous balloon took about 12 hours or so. So I have more fluid, more hardwood ash water now, and more aluminum. So I should get more hydrogen, right? And this has no back pressure, and so it should easily fill with the gas as it's made. So here I'm inside. The inside temperature is 65 on the sink. The bottle is now 46 degrees, so it's come up about 16 degrees. The balloon is 63, and so this should continue to warm up from being inside, A. B, because of the reaction of the two materials. And I'm hoping I don't leak anything out here, but that's pretty tight fitting right there. And there shouldn't be any back pressure to make anything pop off. If worse comes to worse, I can always bring in the duct tape. So that's where we are. And we will touch base later today as this expands. It's very expansive. All right, stay tuned. I just thought I'd show you the change in temperature of the bottle. It's been about 42 minutes, and okay, bottle's reading 50, and the sink is reading 62. So it's come up, I think, another 9 degrees. Another 9 degrees.